any discussion about complex numbers has to start with one definition. And that definition is, let I equal the square root of -1. Up to this point, we've never allowed square roots to have negative radicands or negatives underneath the square root. But when we do this, it allows us to start to evaluate quantities such as the square root of -4, because we can look at it as the square root of -1 times the square root of 4. And now we can evaluate each of these pieces independently. Square root of -1 is I, square root of 4 is 2. So this really gives me I times 2. Or, if I clean it up a little bit, 2I, an imaginary quantity that signifies I have a square root of a negative number. There's nothing unique about this process to perfect squares. I could easily extend it to something like the square root of -8. Think of that as the square root of -1 times the square root of 8, which by definition the square root of -1 is I. The square root of 8 we know is 2 root 2. I could accomplish that with a factor tree. So in the end, if I clean it up a little, I would have 2I root 2, which signifies an imaginary quantity. Lastly, I could speed up a little bit of this process, take for example the square root of -18, and just realize that that negative sign, when he comes out from underneath my square root, becomes an I. So that would give me, in this case, I root 18. And if I use a factor tree, 18 becomes 2 times 3 times 3. And I know that for every pair underneath, I can pull one of those numbers out. So in the end, this quantity would be 3I root 2, again signifying an imaginary quantity. The place that we use these imaginary quantities is whenever we start using complex numbers. And complex numbers are any number of the form a plus bi, where a and b are real numbers, all the numbers that we've always used. And the other stipulation here is that style matters. In other words, I want the purely real part to come first and the imaginary part to come second. Well, how does this look when I start using it in problems? Well, if I'm given a complex number that I need to reduce, something like the square root of -49 plus 8, the first thing I'm able to do is I'm able to pick out the parts that are real and the parts that are imaginary. I can pick out the imaginary part pretty easily because I have a square root of a negative number. Now recall what we just did, and I can change the square root of -49 into something imaginary by pulling out that I and realizing that the square root of 49 is 7. So this is really 7I and plus 8. And since every complex number has two parts to it that don't combine together, this will be my final answer once I put it into the right form, where the real part's first, which is the 8, and the plus 7I is second, the imaginary part. So that's my reduced complex number. If I have another example, something like 3 times the square root of -100 minus 100, again, I can easily pick out the real portion and the imaginary portion. The imaginary portion is sticking out because of that square root of a negative. And I start to simplify this down. I know that when I pull that negative out, I'm going to get an I. And I know that the square root of 100 is 10. So this is really 3 times I times 10 minus 100. Or 30I minus 100. And this is a great answer, but style matters. The order that I write these pieces in is very important. So I rewrite it as -100, real portion first, plus 30I, imaginary portion second. That's my final answer, and that's a quick introduction to what complex numbers look like and what I is.